With the rise of integration between traditional data warehouses and data lakes happening with many customers, the concept of a lakehouse is starting to become more popular. A lakehouse is where you combine the traditional data warehouse approaches, analyze structured and semi-structured data, and combine it with the unstructured or semi-structured data stored in the data lake. For example, unstructured data could be things like images, texts, web pages, all of which need to come together and be understood from a holistic point of view. A lakehouse has the following key features. Transaction support. In an enterprise lakehouse, many data pipelines will often be reading and writing data concurrently. Support for ACID transactions ensures consistency as multiple parties concurrently read or write data, typically using SQL. Schema enforcement and governance. The lakehouse should have a way to support schema enforcement and evolution, supporting data warehouse schema architectures such as star and snowflake schemas. BI support. Lakehouses enable BI tools directly on the source data. This reduces staleness and improves recency, reduces latency, and lowers the cost of having to operationalize two copies of the data in both a data lake and a warehouse. Storage is decoupled from compute. In practice, this means that storage and compute use separate clusters. Thus, these systems are able to scale to many more concurrent users and larger data sizes. Some modern data warehouses also have this property. Openness. The storage formats they use are open and standardized, such as Parquet, and they provide an API so a variety of tools and engines, including machine learning and Python or R libraries, can efficiently access the data directly. There is support for diverse data types ranging from unstructured to structured data. The lakehouse can be used to store, refine, analyze, and access data types needed for many new data applications, including images, video, audio, and semi-structured data and text. There is support for diverse workloads, including data science, machine learning, and SQL and analytics. Multiple tools might be needed to support all these workloads, but they all rely on the same data repository. There is end-to-end streaming. Real-time reports are the norm in many enterprises. Support for streaming eliminates the need for separate systems dedicated to serving real-time data applications. Two examples of data lakehouses are Databricks and Azure Synapse Analytics. Let's look into these with a bit more detail. To give the reliability, robust governance, and performance of data warehouses with the openness, flexibility, and machine learning support of data lakes, the Databricks Lakehouse platform combines the best components of data lakes and data warehouses. By removing the data silos that normally separate and complicate data engineering, analytics, BI, data science, and machine learning, this unified approach streamlines your modern data stack. It is constructed using open standards and open source to increase flexibility. Additionally, its standardized approach to data management, security, and governance enables you to work more productively and develop more quickly. Azure Synapse Analytics is a limitless analytics service that brings together enterprise data warehousing and big data analytics. It gives you the freedom to query data on your terms using either serverless on-demand or provisioned resources at scale. Azure Synapse brings these two worlds together with a unified experience to ingest, prepare, manage, and serve data for immediate business intelligence and machine learning needs.